Children, taking some examples from exercise 5.3, which are on differentiating the given equations, which are either in the form of an explicit function or which are in the form of implicit functions. If you see this first one over here, it is possible for us to express y entirely in terms of x. So either you can write y in terms of x first, then go for finding its derivative, or it can be differentiated as such also. Okay, so differentiating both sides with respect to x. On the left, we get derivative of 2x plus derivative of 3y with respect to x we are doing is equal to derivative of sine x. Now 2x has got scalar 2. So this scalar 2 will multiply with derivative of x with respect to x, which happens to be 1. In the next term, scalar 3 will multiply with derivative of y with respect to x. And on the right side, derivative of sine x with respect to x will be cos x. We need to now only rearrange the terms to get dy over dx. So we see dy over dx is, on shifting this 2 to the right, minus 2 plus cos x over 3. So because this was an explicit function, you could see that the derivative can be expressed entirely in one variable, that is x. Okay, let us take another one. This is the one which is an implicit function. You will find it hard to or difficult to write y entirely in terms of x. You may not be able to even express. So again, proceeding with differentiation in this form only. So differentiating both the sides with respect to x in this form only. Okay, see here. Now I'll do the differentiation directly. You can see this is product of x and y. So while differentiating this term, we need to use product rule. Okay, so according to the product rule, the derivative can be x into dy over dx, then plus y into dx over dx. Keep in mind we are differentiating it with respect to x only. Now derivative of y square. Derivative of y square will be twice of y. But again remember, we are not differentiating with respect to y. We are differentiating the function with respect to x. So the base needs to be differentiated, which is y. So it will be dy over dx. On the right hand side, derivative of tan x, we know it is sec square x plus derivative of y, which is dy over dx. So all the terms including derivative of y with respect to x, I will shift to the left, and those which are independent of it can be shifted to the right side. So if I shift this dy over dx to the left and I take the terms common, you can see from here x can be taken common. From here the coefficient of dy over dx, or we can say the function multiplying with dy over dx is twice of y, and when this is shifted to the left we get minus 1. So this entire term multiplied with dy over dx. Now the leftover terms are, one is sec square x, and if you look at this part here, dx and dx gets cancelled out, it is 1. So this y can be shifted to the right side. Now we can write dy over dx. You can see the derivative is in terms of both the variables x and y, because this was an implicit function. Then see another few examples on differentiating implicit function. Okay, so going for differentiating both sides with respect to x. Fine. So differentiating x cube, derivative of x cube will be, okay, if you want we can involve one more step here. We can first write derivative of x cube with respect to x, then derivative of x square into y with respect to x, then derivative of xy square with respect to x, It can be derivative of x cube, y cube with respect to x, and derivative of 81 with respect to x. Some will get differentiated straight away. Somewhere we will be using product rule. So let us proceed with it. Derivative of x cube will be 3x square. Moving to the next part. Keeping x square as it is, differentiating y, we get dy over dx. Then keeping y as it is and differentiating x square. Derivative of x square will be 2x. Now here also we need to use product rule. So x into derivative of y square. See, when we start differentiating y square, first derivative of y square will be twice of y. But because the function is in terms of y and you are differentiating it with respect to x, so derivative of y will be dy over dx. So the first part is done. Then keeping y square as it is and derivative of x with respect to x will be 1. Now moving on to the last part of the left hand side, derivative of y cube. It will be 3y square, but then again, because it is derivative of y with respect to x, we get dy over dx. What about the right hand side? It is a constant, so its derivative is 0. Now separate the terms containing dy over dx. This is the one, so if I take dy over dx common, I get x square from here. This gives us twice of xy, and this one provides us 3y square. So all these terms have got dy over dx common. Rest all I am shifting to the right. So minus 3x square on the right hand side. Then from here we get minus 2xy, and from here we get minus y square. Now cross multiplying this term, we get dy over dx. Taking minus common from here, we have 3x square plus 2xy plus y square, and the entire term divided by x square plus 2xy plus 3y square. So children, again you can see the derivative can be in terms of both the variable x as well as y, provided it was an example of implicit functions. Okay, this is another one based on that. So quickly doing with this, differentiating both sides with respect to x. Okay, so it will be derivative of sine square y, which can be written as sine y whole square. Then derivative of cos xy. And on the right side, it is a constant, so its derivative has to be 0. Now differentiating it. Now initially it is in the form x raised to the power n, or you can say y raised to the power n. So we need to differentiate that part first. So it will be differentiated using the formula for derivative of x to the power n, where base is in terms of the variable and the exponent is a constant. Then we are going to differentiate sine function and then y. We will be applying chain rule here. So it will be twice sine y to the power 2 minus 1 to the exponent 2 minus 1. Then it is derivative of sine y, which I will take in the next step. Over here we have derivative of cosine function. So derivative of cosine function is minus sine of the given angle. But if you look at the given angle, it is product of x and y, which needs to be differentiated now. So again we are using chain rule here. This is equal to 0. Now this part reduces to 2 sine y. Derivative of sine function is cosine. So derivative of sine y will be cos y. Then it is derivative of y with respect to x. Coming to the next part, sine xy into derivative of x into y. So you need to use product rule here. X into derivative of y with respect to x plus y into derivative of x with respect to x, which is 1. Now you separate the terms containing dy over dx. If you look at this, we can use the formula for sine 2a over here, which is 2 sine a cos a. So it is in the same form, 2 sine y cos y. So it can be written as sine 2y. This gets multiplied with dy over dx. In the later part, x into sine xy gets multiplied with dy over dx. So dy over dx taken common from these two, and the leftover term, which is minus y into sine x in xy, can be shifted to the right side. So it is y sine xy on the right hand side. Cross multiplying this term, we get the required derivative of y with respect to x. So it is y into sine xy divided by sine 2y. Okay, so derivative is y sine xy divided by sine 2y minus x into sine xy. So this was about some examples where we found the derivatives of implicit functions.